Greetings, Mr. Eppstein here. Final topic for these quick reviews, and this is one that you might have been able just to figure out intuitively on your own, as in it's pretty easy. It's expected value. So, if you look in the book, one unit we didn't talk about really was Unit 4. We kind of skipped this one. It's on discrete random variables. You probably remember from our continuity correction video, oh yeah, I know discrete, those are like the integer only data categories. So if you look through this pretty small unit, you'll see problems where everything is an integer value, and there's nothing really new they do that we haven't done with continuous data in there. The only different thing comes from this formula here. We see our formula sheet. Check out these formulas here I circled in red. EX and var x. So E here is for expected value. And you might have guessed var is for variance, which is like the standard deviation squared. Now they also give similar formulas here for continuous random variables, but you'll notice within these formulas we have integrals. So these problems are pretty cool because we know how to do integrals. Therefore, we could do these problems if we wanted, but we won't see any like these on the ACE exam, as in you're not going to use these on the ACE exam. But you theoretically could be asked to use these, although I don't see them very much. But we might as well go over them. They're pretty easy. That's the good news. Okay, so take a look at the formulas there. EX, expected value, is the sum of all x times p. Let's talk about that. I'm just going to talk us through a quick book example, and that'll be it for it. Okay, I'm on page 114 in the book, and they give a table. This table represents the number of people in a car seen driving to work, okay? So let's look at the table just to understand it real quick, and that's always the first thing to do when you look at these problems. Just try to understand the context. Okay, there's 280 cars where there's just one people in them, as in these are people driving alone to work. And there were 300 cars where there's two people in the car, and there were even 4 cars that had up to 5 people in them. Okay, more than 5 people? No, that's ridiculous. No one is cramming people in the trunk of their car. So you might say like, oh, okay, so this is kind of like just like a frequency kind of table. Yeah, it is. The only difference is it's discrete data, as in you can't have half a person in the car. So they could ask you to do stuff like make a histogram, stuff like that. What if they asked it for, okay, what's the expected value of this problem? As in, what's the expected amount of people in each car? They want you to try to combine information for all the categories to figure out what's probable, what's going to happen. It's kind of like asking for the mean. So expected value is a very similar thing to asking what's the center of all the data, what's the mean. To do this, it's pretty simple. Step 1, you need to figure out the percentages for all of these columns. So rather than 280, let's turn this to a percent. How'd you do that? Think about it. If your thought was just, well, I just add up all of the frequencies and then do 280 divided by whatever the sum was, which comes out to 800, then you're right. 280 by 800, 300 by 800, 164 by 800. If you do all those, then you get these percentages. And their word for a percent is a relative frequency. So if you see the word relative, that's their way of saying we're using percent here. And thus, now we have all the percentages. So, following our Nope, wrong one. Here we go. Following our formula here, where it says add up all of the x times p, all you have to do is multiply the probabilities times the x values for each of our 5 columns here, and then you just add everything up. They do it in a fancy table over here. We're here with the percentages we just saw, and RP, they're letting R be the same as X as seen here. And so you just multiply all those things, and if you add them all up, they add to the nice number of 2. And thus you could say, okay, the average car has around 2 people in it. And it was just coincidence that it came out exactly on 2, as in we could get a decimal here as our answer, and that's fine. We might have to round it, but that's fine. If they ask you for, wrong one again, if they ask you for the variance of x, just take a look at the formula. Looks like we're doing something very similar, but rather our x values, they want you to square the x values before multiplying by the percent, and then add everything up like we did for expected value. Then they want you to subtract whatever you got for expected value and square it. And if you compare this formula to formulas right above, yeah, it looks very similar to standard deviation without the square root, where you have something squared minus the mean, and here we said expected value is a very similar topic to mean. And I think they're so similar that maybe if you just saw this on a question and you had never even talked about it, you would have figured out kind of intuitively that expected value is like the mean and probably just got the answer right. So finding variance for our car problem here, I think they show in this table, first they square all of the R values, so 1 squared, 2 squared, 3 squared, 4 squared, and then they multiply them by the percents. They get all these numbers. Then they just add them up to 4.86, and if you wanted to, you could take this 4.86, you could minus what we got for the expected value, which is this number 2, but it's squared, so 4.86 minus 2 squared, 4.86 minus 4, and that's why your variance comes out to 0.86. And they even also show it by adding up this expression if you wanted to do it individually. But following the formula, you would just do 4.86 minus 2 squared, and you get 0.86 as the variance. If you wanted standard deviation from this, all you have to do is take the square root of that. And that's all we got for expected value. Laters.